All right, so let's move on to graphing rational functions. A rational is a polynomial divided by a polynomial, and let's look at what's happening when we divide so if we go 1 over x, that'll be 1 over 10, negative 1 over 10, 1 over negative 1. Now we go 1 over 1/10 is going to be 10, and 1 over 0, undefined, 10, 1, 1/10. And so at negative 10, we're really close to the x-axis. At negative 1, we're at 1, negative 1. And at negative 1/10, which would be really close to the origin, is down here. So we see this happening. Same thing over here. And we have a vertical asymptote. We also have a horizontal asymptote. And due to this division, we get horizontal and vertical asymptotes. So these are going to be a big part of graphing rational functions. Let's talk about how vertical asymptotes occur. So that's important. We want to look for when the denominator is 0, but the numerator cannot be 0. So in this function, we would look for when is the denominator 0. So it looks like the horizontal asymptote is at x equals 1, but then we want to check if we do f of 1, because this is not 0 and this is 0, that means so we saw that this might be a vertical asymptote. We checked in the original function and we found that the numerator is not 0. So that means that is, what we found here is a vertical asymptote. We're going to find out when the denominator is a 0 plus positive or negative 1 makes it 0. And now we check. Let's check f of 1 and f of -1. 1 . f of 1, 2 over 0. So that is a vertical asymptote. And then we're going to go so that means it's not a vertical asymptote. Vertical asymptote at x equals 1, but no vertical asymptote at x equals negative 1. So that's how we find vertical asymptotes. And now we look for horizontal. Horizontal and slant asymptotes. For the horizontal asymptote, we just compare the degree of the numerator and denominator. And I think it's just best to look at some numbers here. All right, so the highest exponent is 1, and the highest exponent down in the denominator is 2. So if the denominator has a higher exponent, then the asymptote is y equals 0. And if we have something like this, you would think of the numerator as having an exponent of 0, and the denominator has an exponent of 1. So it has a higher exponent in the denominator, so we still have y equals 0 because the denominator has a higher degree. We compare the exponents of 4 and of 5. We're looking at this, and the denominator is a higher degree, so the horizontal asymptote is y equals 0. And when we talk about y equals 0, we're talking about that line. So we know that's going to be the horizontal asymptote. Okay, we compare the exponents again, but now they're equal. So when this happens, we take the coefficients. And if we drew that, it would be 1, 2, 3. We would have a horizontal asymptote at 3. So here we're going to compare the exponents, the degrees of the numerator and denominator. They're equal. So we take the coefficients. And if we graph that, this is 1, 2, and it would be at 2/3. We have a horizontal asymptote at 2/3. And if we have this, okay, if we have this and we have a numerator with a degree that's 1 greater than the denominator, then we get an oblique asymptote. And to find the asymptote, we do division. And we're going to go 2x times x, 2x times negative 1, and then we go 2 times x, And we can stop there. We don't care what the denominator, what the remainder is. This is the asymptote. The asymptote is 2x plus 2. All right. So now let's graph. All right. Let's look for the y-intercept. We're going to need to make a table. And then we'll look for the vertical asymptote, horizontal asymptote, and let's look, we could look for a slant asymptote and domain and range. Y-intercept is when the x equals 0. And we have 24 over 0 times all that, so it's 24 over 0. So there's no y-intercept, undefined. Let's look for the x-intercept. That's when the y equals 0. Let's multiply both sides by the denominator. So if we multiply this side by the denominator, it'll cancel. We multiply this side times anything, and it's still 0. And then we get -6 and -4. One, 2, 3, 4, and 6. We know those are x-intercepts. Let's look for the vertical asymptote. That's when the denominator equals 0. So we want to make sure this equals 0. If we set the denominator equal to 0, we'll have x equals 0, x equals 5, and x equals -2. All of these are possible vertical asymptotes. None of them make the numerator 0, so they're all vertical asymptotes, and we can check their h of 0, h of 5, h of -2. If we put 0 into this, we get 24 over 0. And if we put 5 into the original function, we get 99 over 0. Down here we get 8 over 0. So if the numerator is not 0, then these are all vertical asymptotes. Horizontal asymptote, we compare the degree of the numerator and denominator. That'll be x squared and then x cubed. We have x squared over x cubed. Comparing these, the denominator has a higher degree, so we get y equals 0. Slant asymptote only occurs if the numerator is 1 larger than the denominator. So now we have vertical asymptote at x equals 0. That's the y-axis. At x equals 5, 1, 2, 3, 4, 5. Vertical asymptote at 5, and also at -2. Then we need to check some points, so let's check -5. I want to know at 1, 2, 3, 4, 5 what's happening here. So at -5, if we put a -5 into this, we get 1 over 150, and that's a very small number, close to 0, but it's positive, so that means it's just going to be right there. And the graph is going to go like that. Let's see what's happening at -3. At -3, we get -3 over 24. So we have a small negative number at -3. So we know we're going down like that. And then this is going to follow that asymptote. This ends up going down and then following the horizontal asymptote here. Okay, what's happening up here? Let's check -1. At -1, we get 1/2. And the graph is going to do that. Let's check 1. At 1, we get 35 over -12. So almost -3 at 1. And if we check some more points, we're going to find that the graph goes like that. And we check some more points out here, and the graph goes like that, just to save some time. The domain starts from -infinity. It stops at -2, and then it goes from -2 to 0. And then it goes from 0 to 5, and then from 5 to infinity. So we just have to leave out the vertical asymptotes. We have vertical asymptotes at -2, so we have to leave it out. Vertical asymptote at 0, so we want to exclude 0, and we also don't want 5. The range can be a little tricky because we don't know exact high points and low points, but this is going to 0 out here, so we know that's going to 0. 0 is included right here, so it looks like we'll have all real numbers in the range. All right, pause the video and try that one. Here we'll have 3 times -6, 2 times -1, and we get 9. 0, 9 is the y-intercept. X-intercept is when the y equals 0. Let's multiply both sides by the denominator. So we'll go to 0 is equal to the numerator. And if this product is 0, then that means 2x plus 3 is 0, or x minus 6 is 0. All right, x-intercepts. At -1.5 and 6. Y-intercept is at 9. Okay, let's find the asymptotes. The vertical asymptote is when the denominator is 0. So we want to have the denominator equals 0, and we're going to have x plus 2 equals 0, x minus 1 equals 0, -2, and 1. And we want to make sure that those do not make the numerator 0, so we check in the original function. We're going to put a -2 into this, and we're going to get 8 over 0. And so that means they're both yes for vertical asymptote. So now we have vertical asymptotes at -2 and 1. All right, horizontal asymptote, we compare the degree 2x squared over x squared. There are other terms. There are other terms in the numerator and denominator, but we don't care. We're just looking at the 2's, the exponents. They are equal, so we take the coefficients. So we have y equals 2 is the horizontal asymptote. If there's a horizontal, then there's not a slant. All right, let's check some points, and let's look at when you're trying to graph this, we have a few points. We have this point, that point. Let's see what's happening over here. Sometimes people don't know what x value to choose, and you choose anything that you want. So here, let's try -3 and see what's happening. Let's put a -3 into this, and we get 27 over 4. So that is 27 over 4, and we're going to be 1, 2, 3, and 27 over 4 is just under 7. If we checked some more points, we would see that the graph over on this side is going like that. And let's try in the middle. Looks like the graph is going through here, following the asymptotes. And we also have an asymptote. We have an asymptote over here. And I checked also at 2 to see what's happening. At 2, we go to -7. So then we have a point down there, we have a point right there, and we can see that that's happening. The domain has everything except for -2 and 1. And the range, because of this going through the middle, we have all real numbers. All right, pause and try graphing that. So we have 0 plus 0 minus 15, 0 plus 0 plus 3, and we get negative 5. The x-intercept is when the y is 0. Let's multiply both sides by the denominator, and we'll have 0 on the, still have a 0 on the left. And now we just have to factor that as x plus 5, x minus 3. So those are x-intercepts. 1, 2, 3. So we know that much about the graph. Let's look for the asymptotes, and it's going to be when the denominator equals 0, we're looking at what makes the denominator 0, and we're going to have -3, -1. Neither one of these make the numerator 0, so they're both vertical asymptotes. Horizontal asymptote, all we look at are the leading terms, and that gives us, we're looking at the exponents. They are equal, so we take their coefficients. We're just comparing the exponents, so we take their coefficients because the exponents are equal, and we get y equals 1. And there's no slant asymptote. And the vertical asymptote is -3, -1. And we'll check some points. Let's try -2. When we substitute -2, we get -7/15. No, we get 15. So at -2, we go up to 15. Let's try +2, and that's where we get -7/15. At +2, we have -7/15 here. So we follow with the x-intercept. Looks like it's going like that. We have, this is not supposed to be there. It's over here because the vertical asymptote is -1. So we're supposed to have a vertical asymptote at -1, not at +1. And that makes this make more sense. It's going to touch the y-intercept, the x-intercept, and we go like that. The left side is going to be like this, and then the graph follows the asymptotes up there. The domain is everything except for the vertical asymptotes. And the range is harder to determine because we don't know the minimum of that point, so we'll leave the range blank. Okay, one more. Pause the video and try that one. We want to know when does the denominator equal 0? We get -3. -3 does not make the numerator 0, so it is a vertical asymptote. Horizontal asymptote. We're comparing these, and horizontal occurs if we have equal exponents or if the denominator is greater, so there's no horizontal asymptote. And slant asymptote is none, because we need to have the numerator be 1 larger than the denominator. But with this one, we'll go ahead and do the long division. X squared times x, 3x squared, and then we'll multiply by -3x. And this works like the horizontal, same with the horizontal asymptote. We don't care about the remainder. This is going to be the equation of the parabolic asymptote. With a little extra work, we can see that the vertex of this parabola, the vertex, is going to be 3/2 and then 6 3/4. So that helps us sketch that graph. So we have this. We count by tens. And we have vertical asymptote at -3. Vertical asymptote, -3. We have at 1.5, 6 3/4, 1.5, 6 3/4, because since I'm counting by tens, it would be right there. And we have a parabola so it turns out this is going to be a little tough to see without a calculator, but the graph is going like this, and then up here it's like that, and this is actually occurring around 60, but you can check that on your phone or on your calculator. Alright, And it looks like because of this, the range will be all real numbers. And the domain is everything except -3. All right, and that's the end of that.